Hey there and welcome. You know, we use our computers every single day, but have you ever really stopped to think about what's going on under the hood? It can feel like this unknowable magic box, right? Well, today, we're going to pull back that curtain. We're going to figure out how your computer actually thinks. I mean, really think about it for a second. You click your mouse or you tap a key on your keyboard and boom, something happens on the screen just instantly. But what's the incredible chain of events that makes that split-second action possible? It's like a lightning-fast conversation happening between all these different parts. So to wrap our heads around all this, we're going to use a pretty simple but really powerful analogy. For the next few minutes, let's just forget about wires and circuits and all that. I want you to imagine a brain with its own memory and its own senses sitting at a desk ready to work. That single idea, that's going to be our key to understanding everything else. So what is the anatomy of this computer brain? Well, turns out at its very heart, every single computer, from your phone to a supercomputer, relies on three main parts. They all have to work together in perfect harmony. So let's break them down one by one. Yep, pretty much everything your computer does, it all boils down to these three pillars. You've got the CPU, which is the part that does all the thinking. Then you have the main memory, which is where it remembers what it's working on. And finally, the input/output devices, which is how it communicates with you and, the rest of the world. All right, let's start with the absolute star of the show, the central processing unit, or what we all call the CPU. If our computer is a person, the CPU is, without a doubt, its brain. This is where all the decisions get made, all the problems get solved, all the heavy lifting happens right here. But here's the cool part. This brain isn't just one big blob. It actually has three super specialized departments that are constantly working together. Just think of it like this. It's got a powerful calculator for doing all the math, a tiny little notepad for jotting down quick notes, and a manager who's making sure everybody stays on task. First up, we've got the Arithmetic Logic Unit, or ALU. Yeah, that's a mouthful, so let's just call it the calculator. Its job is incredibly focused. It just crunches numbers. It handles all the math and it answers all the logic questions like, hey, is this number bigger than that one? Every single calculation, whether you're editing a photo or playing a game, it all goes through this one spot. Okay, so while the calculator is busy crunching away, where does it keep the numbers it's working on? Well, that's where the notepad comes in. In computer terms, these are the registers, a tiny but ridiculously fast piece of memory located right inside the CPU itself. It's for holding only what the CPU is focused on in this exact nanosecond. So you have to ask, who's telling the calculator what to calculate, or telling the notepad what to write down? Well, that would be the manager, also known as the control unit. Think of it as the air traffic controller for the entire computer. It sends out all the signals telling every other part what to do, when to do it, and in what order. It seriously runs the whole show. Okay, so we've got a brain that can think. That's great. But where does it keep all the information it needs to think about? That question brings us to our next big piece, the computer's workspace, which is its memory. And this workspace, it's kind of split into two main areas. First, there's RAM, or random access memory. This is just like our own short-term memory. It's super fast and great for what you're actively doing right now. But as soon as you turn the power off, poof, it's all gone. Then you have ROM, or read-only memory. This is more like the permanent factory-installed instructions that tell the computer how to wake up in the first place. It never forgets. Now, this idea of RAM connects directly to something you've probably felt. Ever wonder why your computer starts to chug when you have like 50 browser tabs open? You're literally running out of workspace. Getting more RAM is just like getting a bigger desk. It lets you spread out and work on more things at the same time without getting all slowed down and cluttered. It's exactly why pro gamers and video editors need tons of it. Their desks have to be massive to handle all that work at once. And here's another layer to that, which is just a brilliant bit of design. In between that super fast notepad in the CPU and the bigger desk of RAM, there's this thing called cache. It's a small, extra fast bit of memory that's all about one thing: efficiency. It holds the data that the CPU uses most often. It's the ultimate time saver, keeping your most used tools right there at your fingertips instead of you having to walk over to the closet every single time. All right, so our computer has a brain and it has a workspace. But how does it interact with us? How does it hear our commands or show us the results of its work? Well, that's where its senses come into play, the input and output system, or I/O. And these senses, they basically fall into two camps. You have storage devices, like a hard disk. Think of this as the computer's long-term file cabinet, where it keeps things even when the power's off.
And then you have communication devices. These are for real-time interaction. Your keyboard lets you talk to it, and your screen and printer let it talk back to you. They're basically the computer's hands, eyes, and voice. Okay, we've made it to the final piece of the puzzle. We have the brain, the workspace, and the senses. But how do they all talk to each other? I mean, information has to get from one place to another, right? Well, it travels along the computer's internal highway system. This highway system is made up of what are called buses, which are really just electrical pathways. And there are three main types of roads on this highway. One for carrying the actual information, one that says where that information is going, and one for all the traffic signals. So first up, you've got the data bus. The easiest way to think about this is like a fleet of trucks. Their only job is to carry the actual cargo, the bits and bytes, the raw numbers and letters, from one part of the computer to another. But of course, a truck full of data is totally useless if it doesn't know where it's going. And that's the job of the address bus. It doesn't carry any of the data itself. Instead, it carries the location, the specific memory address, kind of like a house number, where that data truck needs to make its delivery or its pickup. And finally, to make sure this whole highway system doesn't turn into total chaos, you need the control bus. This is the network of traffic lights and road signs. It carries all the commands from the manager, the control unit, telling the other parts whether to read data from the highway, write data onto it, or just stop and wait their turn. It orchestrates the entire flow of traffic. So, there you have it. It's not really magic at all, is it? It's just a beautifully organized system. The CPU is the brain, doing all the thinking. The memory is the workspace, holding all the information. The I/O devices are the senses, letting it interact with the world. And the buses, well, they're the arteries connecting everything together. We've basically taken the whole machine apart and looked at each piece. But the real magic, and it does still feel like magic, is seeing how they all work together. The next question is, how do all these parts perform this incredibly intricate dance to execute just a single command in a billionth of a second? So next time you click that mouse, maybe you'll picture that unbelievable lightning-fast performance happening inside, just for you.